Now I'm going to start with the next topic, that is the chemical equation. Now try to understand what the chemical equation is. So I've written here the one definition is that the method of representing the substance which takes part in the chemical reaction together with its product in the form of equation is called chemical equation. It simply means that chemical equation means in a chemical reaction, whatever the substance that are going to react together, and as a result of which the product which is going to obtain, that whole substance I'm going to write in the form of an equation. For example, here I have just written here, suppose when we know that when a zinc is going to react with the sulfuric acid, zinc sulfate and hydrogen gases going to be obtained. Here zinc and sulfuric acid, these are called the reactants, and here zinc sulfate and hydrogen is called the product. So when these two are going to combine together, these two things are going to be formed. So this has been written in the chemical equation form. This plus this, here arrow simply means equal to this. So this is a type of, this is only called the chemical equation. Here a very important thing is that here arrow simply means that the reaction is feasible in which direction. Reaction is feasible in which direction. It means that reaction is going from where to where. It means here zinc and sulfuric acid is going to combine to form, means these two are going to combine to form zinc sulfate and hydrogen. If the arrow is this side, then we can say these two things are going to combine to form these two things. So here arrow simply means that the reaction is just moving from which direction to which direction. Now the next topic is writing a chemical equation. Now it is very difficult for the scientists to write every time the reaction reaction with their name. So what they have done, they have taken out the simple formula that whatever the substance that is going to take part in the chemical reaction, write down their symbols in the form of symbols and the formula. See here, the method of representing a chemical reaction with the help of symbols and formulae of the substance involved in it. जो भी केमिकल रिएक्शंस जो हो रहे हैं, हमेशा उनका नाम लिखने का जो तरीका है वो बहुत ही लंबा है. तो उसको इजी करने के लिए हम लोगों ने क्या किया, साइंटिस्ट लोगों ने क्या किया कि उन सारे जो नेम्स है उनका सारे का शॉर्टकट लिखा इन द नेम ऑफ देयर फॉर्मूला. तो हियर यू नो दैट जिंक इज गोइंग टू रिप्रेजेंटेड बाय Zn, sulfuric acid H2SO4, zinc sulfate ZnSO4, hydrogen S2. So this complete reaction is going to be written in the shortcut form this way. So it is very easy and a convenient form to write the chemical equation. Now merits and demerits of chemical equations. अब ये जो chemical equation हम लोगों ने जो लिख करके रखा है, इसका क्या merit है और क्या demerit है. Means we can simply say that what are the advantages and disadvantages of chemical equations. Okay. So first I'm going to just discuss the advantages or the merits. So name of the compound which takes part in the reaction and product, means we can easily determine or we can just easily say that what are the name of the substance that are going to take part in the chemical reaction and what are the name of the product so obtained. So it is very easy for us. Now we can find the number of molecules and number of atom of each element, means we can simply determine that how many molecules of that particular substance is going to take part in the chemical reaction and how many atoms of particular element is going to take part in the chemical reaction. Also the number of molecules of different products so obtained. I'm just going to tell you one example. Suppose if here written ZnSO4, so here Zn means the zinc, S means the sulfate, and here O is the oxygen, you know. Now molecules, or number of molecules is always going to be written on the first, or we can say before the name, before this compound only. So you know that ZnSO4 is a molecule. If nothing is there, it means one is there. It means we can say that is the one molecule of ZnSO4, and in one molecule of ZnSO4 zinc is how much? Only one. Now sulfur is 1, and here oxygen is how much? 4. Now if I am going to take here 2 molecules of ZnSO4, 2 molecules, so I can say here 2 Zn, means Zn how much here? 2, and 2 into S means how many? This one. Now oxygen 4 into 2 how much? 8. Likewise if I am going to write here 3 ZnSO4, so you see Zn and here 3, it means here 3 zinc, here S, how many S? 3. Sulfur how many? 3, and oxygen 4 into 3, that is a 12, this one. So we can easily determine the number of molecules that take part in the chemical reaction and also the number of atom of each element, that take part in the chemical reaction. Okay. We can determine the moles and mass of the reactant and product. In the class 9th only we have studied that how we can determine the moles, and also we can just find it out that what is the mass of the reactant and the product that is going to be take part in the chemical reaction. Okay. Now demerits or the disadvantage. We cannot determine the concentration of the reaction and the product. Here concentration simply means the purity. Now try to understand that if here I have written here S2SO4. So S2SO4, you know that it is a kind of acid. Now here it has not been mentioned by the formula. You cannot just say that this acid is actually the purest form or in the diluted form. Purest form is also called the concentrated form, and here the diluted form. Diluted form means the strength of the acid is going to be reduced. And how it can be reduced? By adding some solvent in that. Generally we are going to use water as a solvent, because I told you in the class 9 that water is a universal solvent. So if suppose here S2SO4 is taken in the diluted form, so it is not here mentioned that what is the ratio of dilution. Ratio of dilution means that with the water S2O and S2SO4, what is the ratio, but how much water you have taken and how much S2SO4 you have taken, it will not mention here. So we cannot determine that the concentration of the reactant and the product, that how much it is pure, or if it diluted, that how much extent it is going to be diluted. That has not been mentioned. Okay. Feasibility of a chemical reaction. Feasibility of the chemical reaction means that whether this reaction is going to take place or not. Simply I have written, but actually I don't know that this is going to take place or not. Simply I am going to take example. See here that Cu and plus here H2SO4. So one can simply say that this reaction can be written as CuSO4 and plus H2. So we have written like this one, but actually it does take place or does not take place, we don't know. But actually I tell you that this reaction is not feasible. The reason I will tell you later on. So we cannot say that whatever the reaction we have written, actually it will just take place or not. So we cannot determine the feasibility of a chemical reaction. Now the rate of chemical reaction. Rate I told you in the class 9th only. Whenever you see the rate, you just simply assume that we are just going to just discuss about the time. So here the rate of chemical reaction means that when zinc and sulfuric acid is going to react together, then zinc sulfate and hydrogen gas is going to be obtained. But by this equation, we cannot determine that how much time it will take to form zinc sulfate and hydrogen. Either it will take 1 minute, 1 hour, 2 hour, 1 day, 5 days, cannot be determined. So it has not been anywhere it is written that how much duration it will take to form zinc sulfate and hydrogen gas when zinc and sulfuric acid going to react. So the rate of chemical reaction cannot be determined. Okay. Balanced chemical equation and its need. Now the next topic is the balanced chemical equation and its need. Now try to understand what the balanced chemical equation and what is needed. If the number of atom of each element is equal on both the side of the equation, i.e. reactant and the product, it is called the balanced chemical equation. It simply means whatever the number of the atoms of all the elements that are in the reactant side, is it equal to the product side or not? So suppose here zinc is 1, here is also zinc is 1. So we can say zinc is both side 1, 1. Here hydrogen is 2, hydrogen is 2. Yes, we can say both the side hydrogen is 2. Here sulfur is 1, here sulfur is 1. We can say sulfur is both side equal. Here oxygen is 4, oxygen is 4. So we can say all the different atoms of different element on the reactant side is equal to the product side. So when you are able to see such condition, you can say that the chemical equation is balanced. And if it is not equal, you cannot say that. You can say that it is unbalanced. Now the question is that why it is needed. So in the class 9th, I have told you that due to the law of conservation of mass can neither be created nor be destroyed during a chemical reaction. Means the total mass of the reactant is equal to the total mass of the product, है ना? तो किसी भी केमिकल रिएक्शन के समय ना हम किसी भी मास को क्रिएट कर सकते हैं ना डिस्ट्रॉय कर सकते हैं. तो इसीलिए रिएक्टेंट का मास और प्रोडक्ट का मास इक्वल होना चाहिए. तो दैट इज व्हाई इट इज वेरी मच इंपॉर्टेंट टू बैलेंस द केमिकल इक्वेशन सो दैट इक्वलिटी शुड बी मेंटेन. Now, how the balancing is going to be done, that I'm going to discuss. See here, balancing a chemical equation. Now, it is very important to first of just see that whether it is balanced or not. Here, see, Fe means the iron. Here 1 and here Fe3 written. So you can easily just say it is not balanced. So how to balance that I'm going to discuss. So the very easy way of balancing the chemical equation is that just put one line, one side reactant you write, one side product write. What are the reactants are there? Here iron, Fe, how many atoms? Only one. Hydrogen here 2, I've written 2. Oxygen here 1. Fe here 3, oxygen here 4 and hydrogen here 2. Now you can see this side iron 1, this side 3, hydrogen 2, 2, oxygen 1 and here 4. So you can see that only the hydrogen is balanced but other atoms are not balanced. So how to balance this, that I am going to discuss right now. Okay. Now the very important thing is that during the balancing of the chemical equation that you can only change the number of the molecules of a particular substance. Means suppose just now I explain you that suppose ZnSO4. So if you wanted to make any change in this compound, so you can only increase or decrease the number of molecules. You can write here 1, 2, 3, 4 or whatever you wanted to write, you can write. But you cannot change the formula of the given compound. So it simply means that you can only change the prefix, but you cannot change its suffix. मतलब फॉर्मूला के अंदर में जो भी चीजें लिखी हुई हैं उसमें आप कुछ भी चेंज नहीं कर सकते हो. फॉर्मूला के पहले की सारी चीजों को आप चेंज कर सकते हो. उसके पहले जो भी नंबर लिखा है 3, 4, 5, 7, 8 जो भी आप चेंज कर सकते हो. Now one more thing, during the balancing you cannot write the fraction before the formula. फॉर्मूला से जस्ट पहले आप फ्रैक्शन नंबर नहीं लिख सकते हो. जैसे आप यहाँ पे ZnSO4 है तो आप इसको कभी भी 2/3 ZnSO4 कभी नहीं लिख सकते हो, क्योंकि कोई भी जो मॉलिक्यूल्स है वो हमेशा एक आप कह सकते हो कि होल नंबर के फॉर्म में होता है, वो कभी फ्रैक्शन में हो सकता है. जैसे फॉर एग्जांपल अगर मैं बोलूंगा जैसे यहाँ पे कितने सारे स्टूडेंट हैं तो मैं बोलूंगा यहाँ पे 5 स्टूडेंट है, मैं कभी भी नहीं बोल सकता हूँ कि 5/3 स्टूडेंट्स है. तो स्टूडेंट्स कभी फ्रैक्शन में नहीं हो सकते. तो वैसे मॉलिक्यूल्स जो है वो कभी फ्रैक्शन में नहीं होंगे, जब भी होंगे वो होल नंबर के फॉर्म में होंगे. ओके. Now, so I told you that if you wanted to do any change in that, you can only change the number of the molecules, but you cannot do any rectification in the formula of the given compound. Now, this you should keep in the mind. Now, the next important point is that while balancing, you should try to balance the substance which is alone. जो अकेले है, जो सिंगल है. जैसे फॉर एग्जांपल आप यहाँ पे आयरन और हाइड्रोजन ये दोनों एलोन है तो इसको सबसे आखिरी में बैलेंस करना चाहिए, क्योंकि उनको आखिरी में बैलेंस करना बहुत इजी होता है. हाउ? ट्राई टू अंडरस्टैंड. सी है. तो फर्स्ट ऑफ ऑल आई एम गोइंग टू सी with the iron here 3 is there and here 1 is there. So if I wanted to balance the iron, I cannot write here 3. Just now I told you that we cannot change the formula. We can increase or decrease the number of molecules. So suppose if I will write here 3, so this iron I have multiplied with the 3, it becomes 3. Now you see that iron has become 3, this side also 3. Now we see the oxygen is balanced but the hydrogen is not balanced. Now see, this side oxygen is 4 and this side only 1 oxygen is there. If I am going to put here 4, I can see that 1 into 4, it has become 4. Oxygen in balance. But while putting here 4, you see the number of hydrogen is also changed. Why? Because 4 into 2. So here 4 into 2, it has become 8. Now you see, while balancing the oxygen, hydrogen has disbalance because here 8, here 2. So we have just balanced here what? Iron, and we have just balanced here oxygen. But during the balancing of the oxygen, the hydrogen is disbalanced because here 8, here 2. So this can be simply balanced. Here 2 is there. If I am going to here put 4, so I will see here 2 into 4, 8. Now you see that all the atoms of the reactant and the products are equal. 3 and here 8 and here 4. So this way we can just simply balance the chemical equation. Now one more example I have taken here. See here. NaOH plus H2SO4, Na2SO4 plus H2O. Now here, NaOH. So you see, Na, sodium 1 and oxygen here, 4 and 1 here, 5 and here 1 sulfur and hydrogen are 2 and 1, 3. And see here, sodium here 2, sulfur only 1, oxygen 4 and 1, 5 and hydrogen 2, only 2 here. Now, so we are going to start the balancing with the sodium. Why? And one more thing, that try to start the balancing with the bigger compound, means the formula that contain the maximum number of the elements. Okay. So here you see, here Na is 2. Now, if I am going to multiply here 2, then I will see here Na is 2. Na2 balance, but while balancing here 2, you see the oxygen has also become the double. So how many oxygen will become? 2, and here 4. How many oxygen will convert? It will has become 6, because here 2 oxygen, and here 4 becomes 6 here. So you see the oxygen has this balance. And now I'm seeing hydrogen. Hydrogen how many? 2 and 2, 4. Hydrogen has changes to 4. So while balancing the sodium, some other changes has also been done. Now I'm going to just balance the sulfur. So sulfur is here 1, sulfur is this side also 1, balanced. Now I'm just going to balance the, now we are going to see oxygen. See here, oxygen. So here 4 and 2, 6 is there. Now see here oxygen is 4 and here oxygen is 1. Now, if I'm going to multiply here 2, so you see 4 oxygen and 2 oxygen. The oxygen has changes to 6, and hydrogen how much? 2 2s are 4. Only 4. It has changes to 4. Now you see what the changes are seen. Sodium 2 2. Okay. Oxygen 6 6. Okay. Sulfur 1 1. Okay. Hydrogen 4 and 4. Okay. Now all the reactant side and all the product sides are equal. So we can say this reaction has been balanced. So I told you, once again I'm going to tell you, whenever you wanted to just balance the chemical equation, you can only change the number of the molecules, but you cannot change the formula of the given substance. I hope you have understood. Thank you.